Hi everyone. This question has been taken from Olympiad Pathfinder NLM MCQ question number 70. The question says two blocks A and B, each of mass m, are connected by an ideal string that passes over two fixed ideal pulleys. So what is this ideal string? Ideal string, you should consider it as massless and inextensible, means its length will remain constant even when it is loaded. Okay, and ideal pulley means the pulley is massless, no mass, and frictionless. So the blocks are also connected with the grounds by springs of force constant K1 and K2, where K1 is greater than K2. So in this block A is connected with a spring which is having a spring constant K1. Similarly, block B is connected with another spring with a spring constant K2. Both the spring at the other end is connected with the ground. Okay, initially both the springs were in relaxed length, means there was no compression or elongation of the spring in the beginning. Question further says when both the springs are relaxed, okay, the block A is pulled down a distance x. Block A is pulled by a distance x downward and released. So what is happening when you are pulling the block A downward? Spring 1 is getting compressed. Okay. Block A is connected with the string, inextensible string, with block B. So block B will move upward by x distance, right? So this spring, number 2 spring, that K2, will be elongated by x, right? Again, it is saying that acceleration magnitudes of the blocks A and B immediately after releasing are A1 and A2 respectively. So this block acceleration is A1, this block acceleration is A2. Okay. So mark the correct option. So there are 4 options given and we have to find out which all options are correct because it is a multiple choice question. Okay. In the question, so I have written here like MA is equal to MB is equal to M and K1 is greater than K2. This is as per the question. So we will make the free body diagram of A and free body diagram of B block and see which all forces are acting, and we will apply the Newton's law of motion on that. Okay, that is the way to proceed. So here is the free body diagram of block A, in which all the forces have been shown, that which all forces are acting on it and in which directions. So mg is the weight of mass of the block A, which is acting downward, which will always act downward. Since spring 1 was compressed, so it will exert an upward force on the block, and amount of that will be, and the magnitude of that force will be K1 into X as per the Hooke's law. And T is the force exerted by the string on the block M in the upward direction, right? A1 is the acceleration shown here. So if we apply Newton's law of motion on this block A, we will get the expression T plus K1x, T upward, K1x upward, so both are positive. Mg is acting downward, so minus Mg will be equal to Ma1. And let us say this equation number 1. Similarly, for free body diagram of block B, you see string force is upward, that is T. Weight of the block is acting downward, Mg. Spring force here will be acting downwards. Why? Because number 2 is spring is elongated. So when it is elongated, so that spring will try to regain its length. So it will pull the block downward, right? A2 is the acceleration. So we shall write the Newton's law of equation by applying the Newton's law of motion concept, that net force acting on a body is, or on a mass, is equal to the mass into acceleration of that block. So K2x is acting downward plus Mg is also acting downward, so K2x plus Mg. T is acting in the upward direction opposite of Mg plus K2x, so it is minus T, and this is equal to mass into acceleration of number 2 block. Okay, let us say this equation as number 2. If you see the options, in options, what is being compared is A1 and A2, right? Okay, so we have to think from that perspective to solve these questions, right? So case 1 we can consider where we say that acceleration of block A is greater than acceleration of block B, that is A1 is greater than A2. Okay, so what is happening in this case, when the block A is moving upward faster than the block B coming down slower, so string will get slack, so tension force will become 0. So our equation 1 will become this, K1x minus Mg is equal to Ma1. This we say as equation 3. Similarly, the equation 2 will become K2x plus Mg is equal to Ma2, number 4 equation. In the question, and if you see the options, it is always number C and number D is the expression with the inequality, right? So what we will do, A1 is greater than A2, so means A1 by A2 will be greater than 1. So to achieve that, to use that, we divide equation 3 by 4. Sorry, I have written here 1 and 2, so you can correct it. Okay, so dividing equation 3 by 4, you will come to this equation number 5. Okay, and A1 divided by A2 is greater than 1, so we will use this, and finally we will be able to equate K1 greater than K2 plus 2mg divided by x, which is your option C. So option C is one of the correct option. Okay, we will check the other options as well. In second case, if we take A2 is greater than A1, means block B coming down faster than block A going up. This can only happen when your string is broken, otherwise not. So there is no as such option given in your question. So this case we can discard. Now third option, both the blocks are moving with the same acceleration. So in that case, what will happen? Your tension will either be equal to 0 or greater than 0, right? Okay, means thread will be under tension, or it will not be under any tension but will move together. So for that we will subtract equation 2 from 1. We will come to this expression, and from here finally we will come to get K1 is less than equal to K2 plus 2 mg by x. This is what is given in the option D. So means option D is also correct. So our answer will be option C and option D. Hopefully you understood the concept behind solving it. In case any problem at any stage or any doubt, please write your doubt in the comment box. I will clarify that. Thank you.